Right, so today we're going to talk about linear graphs. So there are actually three parts to this video. Number one, we want to get the equation of the straight line. Number two, we want to interpret a linear graph and what it can tell us. Number three, we're going to draw two linear graphs to solve a pair of simultaneous equations. Right, so let's look at the first part, and anyway you can skip to any parts that you like because there will be like a chapter sections in the timeline of this video, so you may skip to the parts that you find useful. Right, so let's start off with this one. So this question says to get the equation of the straight line in the form of y equals mx plus c. So as you can see, this straight line here is given, and there are two coordinates that are given to you, but there are actually many coordinates on the line, right? So as you can see, you can have this point here is a coordinate, this point, and so on and so on. There are many sets, many coordinates on this line, but two of them are written for you. Okay, so the first number on this coordinate is the x coordinate. So it gives you the position in the x according to the x-axis. So as you can see, when we draw a dotted line up, so this is x equals to -3, and the second number gives you the y coordinate, which is -4, right? So in the form of y equals to mx plus c, so all linear graph will have this very general form. So what makes the equation unique? It will be the value of m and the value of c. So as you recall, m stands for, right, the gradient. So it tells you how sloping is the graph, okay, whether is it very steep or is it very gentle. So imagine like it's like a mountain, a slope, so how gentle, how steep it is. So for c, it represents the y-intercept. So y-intercept is exactly what it says. It is the point at which the line cuts the y-axis. Okay, now let's try to just get the value of m first. So we're going to calculate the value of m, which is actually your gradient. Okay, so in lower secondary, if you have learned it, we call it the rise over run. So basically, rise refers to, for example, I'm going to make use of these two coordinates that are already given, -3, -4, and 2 and 6. So rise would be, so I'm going to draw a, so one of the things that students should learn to do is to draw a triangle. It will really help you to see the value of rise and run. Okay, now over here, you can see that from this point to up there, this is the rise. So rise is like the vertical height of this triangle. Okay, rise, right? And this would be the run. So the horizontal part will be the run of the triangle. Okay, so to calculate the rise, we will take the y coordinate minus the other y coordinate, right? So we're going to take 6 minus -4. And when we're going to calculate the run, we're going to take the x coordinate, the difference in the x coordinate, so it's 2 minus -3. All right, I hope this is so far so clear. Then we just calculate as it is. So 6 minus -4 would give me 10. 2 minus -3 would give me 5. And that tells us the gradient is 2. So that's the first part that we need. Second part is to get the y-intercept. So the y-intercept is equal to the y value when the line cuts the y-axis. So it's right here. So therefore, y-intercept is equal to 2. So now we're going to put in the value of, so this is actually C, just so that you know. So C is the y-intercept. So therefore, we're going to put in the value of M and C. So we have y equals to 2x plus 2. So this will give you the unique equation for this particular straight line. Well, we can actually do a double check whether we got the equation correct. So let's say when x is equals to 1, what will be the value of y? So we know from the graph it's supposed to be 4. So if we get the equation correct, then we will be able to use the equation as well. So when x is equals to 1, y is equals to 2, and we put in the value of x plus 2, so yep, we got y equals to 4. So therefore, this is just a quick check that we got the equation correct. So therefore, this equation is representative of this particular straight line. And this is the final answer. All right. Right, so now what happens if it is a downward sloping line? And how are we going to get the equation of the graph? Don't worry, it's still the same. So let's recall the general form of the equation, which is y equals to mx plus c, right? So we have to get the m. So do you remember what m stands for? Right, so that is the gradient. And the c stands for, recall, y-intercept. That's correct. And now let's just do the same thing again. So don't worry, we gotta read two coordinates. So we always choose, so I always tell students to choose coordinates that are convenient, that snaps to the grid, okay? So probably I will not choose things that are like in the middle of nowhere, like here. So I will not choose this particular coordinate because it's really hard to read. And therefore, I will choose the coordinate. Right, so maybe this one. Okay, so that will be 0, 2, and here, which will be 4, 0. All right, so we choose 2 points to calculate the gradient. Okay, so let's just start. First and foremost, remember, we're going to draw the triangle that will help us to see the triangle first. So this is the triangle, and this is the one to help us look at the, so now, right, instead, because it's downward sloping, so I kind of call it the drop. So rather than rise, right, it's easier to think of it as a like rolling down slope. So it's like a drop. And this is still the run. All right. So, but the method is the same. Okay, no change in the method, I promise. So let's calculate the m, which stands for the gradient. Now, the gradient would be equals to, so instead of a rise, it will be like the drop over run. So it's the same thing. Right, so how do we calculate the drop? So first, we want to find the difference in the y coordinate. So I will take 0 minus 2. Okay, 0 minus 2. So I'm getting the difference between the height. Then to get the run, I will use 4 minus 0. 4 minus 0. Right. So far so good. And here we will have minus 2 over 4. And this will give me negative half. So the negative sign is perfectly fine because it is a downward sloping line. So therefore the gradient is negative. So for upward sloping lines, the gradient is positive. Okay, let's see how we can calculate, or no, how we can get the y-intercept. So we need the c, which is your y-intercept. So for the y-intercept, you can see that this line cuts the y-axis at 2. therefore, the y-intercept is 2. So now we can put in this value. So we can put in this value so that we can get a unique equation for this particular line. So y equals to mx plus c. So m, it's minus half. C would be 2. So this would be the equation for this particular line. So like I said, maybe we should give it a check, right? So let's do a check here. So you don't always have to check. Well, if you have time during the test, it's good to just give it a check. So I'm going to use this particular coordinate to check. See the one that I marked on the graph right now? So the coordinate is when x is equals to 2, I'm expecting y to be equals to 1. So let's see if that's true. So I'm going to substitute in x is equals to 2, right? So x is equals to 2. Okay, y is equals to, so 2 times minus half will give me minus 1. And therefore y is equals to 1. Right. So this equation is good to go. Right, this part is related to interpreting and understanding the graphs, because graphs are actually meant to be useful. They're just not like steps that we're going to follow and just do it, you know. But in this case, we just showed an example of how possibly graphs can actually be useful. Now the first part, it says to calculate the gradient. So this graph actually shows the rate at which a water tank is being filled, and the volume of water is on the y-axis, and the x-axis gives you the time in terms of minutes. Now let's calculate the gradient of PQ, right? That's what the question asked. So remember, we're going to draw, the triangle. Okay, so first we're going to draw the triangle so that it helps us to see like the rise and the run. And we want to write down the coordinate because it will help. So coordinate of Q is 6, 49. The coordinate of P would be 0, 25. Okay. So given that this part would be the rise and here would be the run. So we're going to start calculating the gradient of PQ. So the gradient of PQ is rise over run, and we have a upward sloping line, so we expect a positive gradient. So we're going to take the difference in the height. So it's 49 minus 25. And for the run, it would be 6 minus 0. So the difference in the x coordinate, so it's 6 minus 0. Okay, so what we have here is 4. So that's for part 1. Now let's look at part 2. Well, let me use a slightly different color. Okay, so for part 2, we're going to calculate the gradient of QR. So the gradient of QR, similarly, don't forget, we're going to draw, the triangle, so that it helps us to see which rise and run we're going to be using. So from Q to R, so this shall be the rise, and this part is the run. So it's between Q and R, and we want to write down the coordinates that we're going to use. All right, so this is 14 and 69. This will be 6 and 49. Oh, we already have that. How silly of me. Okay, so we have rise over run. Yep. Okay, so let's get the difference in the height. So we will take 69 minus 49. So far so good. So that's the rise for QR. And let's see what's the run. So the run would be the x-coordinate of R minus the x-coordinate of Q, which is like the horizontal difference. So that will be 14 minus 6. All right, so we're going to have 20 over 8. So that will give me 2.5. All right, so we already have part A. Now the last part, we have to interpret what the gradients actually mean. Now if you realize, you actually use rise over run. So rise actually would be the difference in the volume, isn't it? So which we are actually calculating from 0 minutes to 6 minutes. What's the difference in the volume? So basically, you're looking at the volume divided by the time taken. So can you imagine? So when you're calculating the gradient, the rise actually represents the volume of water, the difference in the volume of water divided by the time taken for this very specific case. Of course, it can be other cases if the question has a different context. So, but in this particular case, we're talking about volume of water divided by the time taken. So the gradient tells you how much increase in the volume of water per unit time. So basically, for part 1, the amount of water being filled per unit time, it's 4 meter cube per minute. Whereas for the later part in QR, the amount of water has been filled 2.5 meter cube per minute. So basically, the gradient represents the volume of water filled per unit time. So as you can see, for QR, the amount of the volume of water filled per unit time or per minute is actually lesser, and PQ, the volume of water filled per minute, is more. So in this case, the graph, just one look, you have an idea. You can see from the gradient, PQ is steeper and QR is actually gentler. So we can tell that water is filling fast at first and a bit slower later. Right? So this is sometimes how we use graphs to interpret, and it has a meaning to it. All right, we've come to the third part of this. It's also related to graph, but we're going to use, recap how to draw a linear graph. Okay, so instead of getting the equation, this time around the equation has been provided for you, and we need to draw it on this graph paper over here. And after that, we're going to use it to solve this pair of simultaneous equations graphically. So when the question asks for graphically, you have to show the graph. So of course, we know that there are two other methods that we could use to solve simultaneous equation. One, we call it elimination, and the other one is called substitution. But this time around, we're going to look at it graphically. All right. So the first part, I've already done the table here. So we always have to get like a few coordinates in order to draw the graph. So let's start off with 0, 1, 2, 3, 4. So we're going to start off, sometimes the question might already tell you the suggested or like instructed values of x. So, but in this case, I'm suggesting 0, 1, 2, 3, 4. Okay, so let's just try this. So I'm going to just show one example. Now, when x is equals to 0, then you substitute x equals to 0, into the equation to get the value of y. So as you can see here, y is equals to -2. So you can pause this video and try this on your own. So if you're not sure of the second one, let's try one more. So when y equals to 1, so when x equals to 1, I'm sorry, y is equals to 3/4 times 1, so I'm substituting x equals to 1 here, -2, so that would give me -1 and 1/4. Okay, so do pause the video and try filling it up. Right, so I hope you have filled in the first, the coordinates for the first equation. Now let's take a look at the second one. Now the second one looks a little bit different, but don't worry, it's actually the same. So what we're going to do is we're going to bring y on the left side, or leave y on the left side, and we'll have x minus half x, so we bring it to the right side. So this will help a lot. So it's easier for you to see when you substitute your x value. So let's try the first two, and after that I'll leave you to try and put in the values for the last three y values. So let's try this. So when x is equals to 0, so I'm filling the first column, y is equals to, so I'm going to substitute the value of 0 for x, right? And we get y is equals to 3. So I'm going to put this here. Next, we're going to have x is equals to 1. So y is equals to minus half times 1 plus 3. So that gives me 3 minus half, and I have 2.5. Right. So I have 2.5 here. Okay, so I'll leave you to do the rest. Alright, so I hope you have filled in all of these, and now we're going to start drawing the graph. So before we draw, I always remind students that we have to be planning a little bit. Alright, so let's plan a little bit. So for x-axis, okay, so let's just do a bit of scribble here. So don't worry about like messing it up. It's okay, we'll erase it later. So for x-axis, we're going to have 0 to 4. Okay, let me just imagine we have 0 to 4. Okay, and for y-axis, we need to cover the value of -2, -1/4, 1 for the first graph, and 3 as well as 1 for the second graph. So which means that I have to have at least the value of 3, at least, and -2 over here. Alright, so if that's the case, that's where I'm going to try to put in the axis. So I'm going to put in the axis here. Okay, maybe I shall use a pink color so that it's a lot easier to see. So when you're doing, make sure your pencil is sharp and draw in pencil, because in case you need to erase, it will be much easier. Okay, let's put this here. Okay. So usually in exams question, for if you're in lower sec, maybe your teacher would give you some suggestion or already instructed in the question how you want to draw the axis. But if not, then some planning is required. So that's how we're going to plan for it. Okay, let's see. Okay, this shall be my x-axis, and this is y, x. Okay, so minus, so it's 1, 2, 3. So maybe I can do a 1, 2, 3, and sometimes I just include one more, 0. So -1, -2. Okay. And for this, I'm going to do 1, 2, 3, 4. So if I were to use 2 big squares, I wouldn't have enough. Alright, so well, let's start plotting. Okay, I'm going to use Because sometimes we don't have the luxury of colors, but now I have, so I'm going to use colors. So we have 0 and minus 2 for the first point, 1 and negative 1 and 1/4. So that would be 1.1, 1.25, so it's around here. So negative 1 and 1/4, 2 and minus half, which is right over here. Okay, 3, and this would be here. Oops, sorry. So we can tell like, oops, it doesn't look like a straight line, so I must have made a mistake. So 3 and 1/4, yeah, that looks more like, so 4 and 1. Okay, so we have this, and we're going to draw this straight line over here. Okay, yeah, we have to try. So the thing is, because I'm drawing it digitally, I'm just trying very hard to pass through every point because it seems to snap to grid on its own. Okay, so I'll just draw as and then I'll make some adjustment. Let's see how we can do that. Okay. Okay. Right. It's coming to work a little bit better. Okay. Yeah. So, but that point looks a little bit out. Okay. Let's try to fit it in. All right. So please check on your graph that hopefully we can get everything in. And yeah, so maybe I should redraw this a little bit. Perhaps it's not very accurate. So I think my screen just shifted. Oh dear. Yep. Finally. Okay, so let's do it 3 2/4 here. Yeah, just right there. Okay. So don't forget to label your graph because you have two graphs here. So let's just label it y equals to 3/4 x minus 2. Alright, so we have a luxury of using a different color for a different graph. So let's do this other color. So the first point is 0, 3. And the next point is 1 and 2.5. Right? Then 2 and 2, which is over here. 3 and 1.5, we have it here. Okay, and 4, 1, right on here. So we're going to draw the graph. Oh, this fits really nicely. Okay. And I have to write the equation y plus half x. So I write the original equation that was been given in the question. So this shall be the graph. So now we have two straight line graphs. And to solve the simultaneous linear equation graphically, what we are trying to get is the intersection points. So when we are solving, every time in maths when we say we're solving, we're actually trying to see what are the points that coincide with these two graphs, these two lines. So the intersection point is the answer. So of course, so let's look at this. So the answer to this question is the intersection point. So the point that the coordinates of this intersection point, this intersection, is 4, 1, right? So therefore, the solution for this pair of simultaneous equation will be x is equals to 4 and y is equals to 1. So in this case, we are actually making use of the graphical method and drawing of the two straight line graphs to solve the simultaneous linear equations. So you realize that all the graph skills that you use are often connected chapter to chapter, like different chapters, and they're always useful. Alright, so I hope this video helps your graphs stuff. Thank you.